Awesome. Hi, everybody. I'm super excited to be here. Thanks for coming. I just came from ACL, the conference, too. Let's make this very interactive. So if I say something that you don't understand, you have any questions, just let me know. I'd be happy to interrupt the talk. I don't want to sort of give a bunch of slides about stuff that isn't really understandable to you. So just to gauge the audience, who here could write or understand the equations of an LSTM? Can you raise your hand? All right, good to know. All right, so around a third of people. So yeah, we'll go through it, and the beginning is kind of high level, and I won't go into too many of the technical details, but there will be papers and so on and references for those of you who really dig into LSTMs. So this is a talk about a new direction of research, and it kind of came about from us thinking about what the field of AI has kind of done in the last couple of years and decades. And I've sort of seen it now, and I guess my affiliation is I'm chief scientist at Salesforce right now and adjunct professor at Stanford. And so before Salesforce, I had a startup. And so I have kind of seen AI now from a variety of different angles of startup world, big company world, academia, industry, and so on. And so basically, in the last couple of years, we have gone through various stages. And one of them are, or you can kind of see them as first having done machine learning where we did feature engineering. So back in the day, if you wanted to build, and this was like the 90s, early 2000s, if you want to build like a sentiment algorithm, you would go out and say, oh, I know all the positive words and negative words. So I just count them, and I use a machine learning algorithm to give me weights. And so awesome would have a really high positive weight, and good might have just a low positive weight. And the algorithm would learn that. But you kind of told it what it should weigh. And then you realized, oh, but then there's negation. And you say, well, not something positive from this list, and that's a new feature, and that gets weighted, and things like that. And then you realize, well, that works well for sentiment, but if you try to do something like that for translation, it's going to be really hard, because there's way too many rules. You can't really write them all out, and so on. Then deep learning came about, first in computer vision and speech recognition, and now also in natural language processing, where we can actually learn the features instead of having them manually described. And now we're sort of in this time where we're doing architecture engineering, where we have neural networks, and the neural networks technically learn a lot of the features, but in practice we have still some intuitions about the task, and we can kind of change the architecture and make it very specific for each task. And so when you look at where we are right now, you basically realize that we're actually quite good when it comes to a setting where we have a single data set, a single task, a single model, and a single metric. And we're just optimizing in that kind of setting. We can hill climb over the years as long as your data set is roughly 1,000 times the number of classes that you want. So if you do image classification, you have 1,000 representative examples of cats and 1,000 of dogs. You can probably do over 90% accuracy in classifying cats versus dogs. And that is kind of true for a lot of other things. So in translation, for instance, if you assumed each word is its own class, which is often the case for current machine translation algorithms, you'd want a lot of words, millions of words. And then you eventually get to be reasonably good at translating reasonably frequent words. But really, as you've seen with this dog, this is kind of how the community is currently working. You run into a problem, you solve the problem, and then you restart from scratch, and you kind of forget what was happening before. So every one of our AI projects starts from random weights. And whenever there's a new problem, people, again, try to fiddle around with different architectures and so on. And it would be much nicer if we could, instead of from random, start from a pre-trained model that has already a reasonably good understanding about the world, and you just put your task on top of that and go from there. And so we've seen some of that success in computer vision, where most computer vision projects at this point would start from a convolutional neural network model. And if you don't know what that is, it's OK. We don't have to go into all the details. It's essentially, at this point, a bunch of API calls that are very, very simplified for most people. And you have a pre-trained version of that that was actually trained on identifying 1,000 different visual categories. And that convolutional neural network, or we call it ImageNet pre-trained CNN, CNN short for convolutional neural network, will essentially be a really good starting point for most other vision problems that you might have. And most people, whether you're trying to identify issues in radiology images or try to build a self-driving car based on camera inputs, you'll use some kind of convolutional neural network. And as long as it was kind of photos or standard visual inputs that you see in the natural world, it'd probably be pre-trained with ImageNet, which is just a large data set. And so most of the vision community was kind of in agreement that just identifying objects was a major blocker. Like, people have published all kinds of amazing papers of scene understanding, but they couldn't really identify cats versus dogs. So most of the people in the community agreed that if we can't really do classification, it doesn't really make sense to go much beyond it. And then thanks to deep learning and these large end-to-end trainable networks, we were actually able to make a lot of progress. Now, we haven't seen that kind of progress in natural language processing, largely because there isn't a single task for natural language processing where everybody's like, oh, if you can solve that, clearly you solved NLP, or you've made a major advancement. Because we have machine translation folks, and they have very different kinds of models to sentiment analysis folks, and to people who just try to understand grammatical structure in sentences, or people who try to summarize documents. All of these have different subcommunities and very different kinds of models. And some issues in NLP require logical reasoning, and others more fuzzy reasoning. So for instance, the people who try to have an AI algorithm answer the question, given the input, 2 people were in the room, 1 person left, how many people are in the room? That is one set of people. And the people who say, this was a typical Nicolas Cage movie, is that positive, negative, or neutral in sentiment? I'll let you decide. Then those are completely different communities and different kinds of models that they're working on. And they're all kind of hill climbing at this point into these different subcommunities and trying to make progress. And so there are a couple of reasons here. They also sometimes require long and short-term memory. Some things in natural language you just kind of know. For other things, you need to actually refer to a specific document to get to the answer. And we've basically tried to, as a community, divide and conquer the field of NLP and kind of arbitrarily, in some cases, split the community and say, all right, you guys are summarization folks, you guys are question answering folks, and you do, translation and things like that. But now that we have this ability to hill climb, and basically with any large data set, find at some point some neural network architecture that will do a reasonably good job, I think we as a community can bring some of these back together and shoot for more complex, more general systems. And that kind of leads us to the question, why should we try to put all of these back together? You might say, well, if we just want a translation system and that's all we want to do, then that's fine. But I would argue that having a single system is actually a necessary step to actually having a general natural language processing system that eventually you could just have a natural conversation with and it'll just work and be able to give you the answers that you want. There are some more sort of down-to-earth reasons for why would you want that right now in a company, and that is it's much easier to deploy. And in general, there's a lot of complexity in that deployment. You can also think about some very specific tasks, like trying to have a bot, a natural language chatbot that a company puts on their website, and if you have a question, instead of calling them, you just ask this chatbot. And now currently these chatbots are very brittle, and they basically try to classify your intent, like, oh, is this a service question or a billing question? And then they classify that with some accuracy, and then they put you into a decision tree, and then they try to identify certain slots. All right, if it's a service question, like, what is the contract that you have? And you have like 5 options and so on. And as soon as you move out of that decision tree, you're kind of screwed. It won't work, and it's very brittle. And if you then all of a sudden you start cursing, there's a separate classifier that says, all right, if the sentiment gets too negative, then let's have a person talk about this. And you basically have all of these different subsystems, and they're all calling each other based on some very specific thresholds that you set. And if you had instead a single model, then it would be much easier and much more general. And you would eventually get to things like transfer learning and zero-shot learning, and I'll talk about what that means. But it's basically going to be the ability to answer questions you've never actually seen in your training data. And that is kind of amazing that that could work at all, and it does in some cases, and we'll get to that in a bit. You have other nice things like domain adaptation and more technical things like sharing weights and models, similar to what we had in computer vision if we had the single model. And so you can then think about, okay, if we want to try to solve all of the different NLP problems in a single model, it's a pretty ambitious goal. I would argue that there are 3 what I call equivalent super tasks of NLP. And what I mean by that, basically, those are tasks that you can map every other NLP task into. So language modeling is technically just the task of predicting the next word in a sequence of words. But really, that means I have a question, and the next words that you predict are the answer. And you can say, you have a text in German, and then you ask what is the translation into English, and then the next couple of words you want to predict are that translation. And so on. So basically, everything is kind of language modeling. The way we're currently using language modeling is mostly trying to identify reasonable word sequences and seeing which word sequences are more probable. So for instance, if I ask you, would you give me the price of wood, on the stock or on the markets or whatever, then you have 2 woods and they sound kind of the same. And the language model would just tell you, well, the first wood is probably the W-O-U-L-D, and the second one is more likely the W-O-O-D. And because they're more likely in that context. So these are pretty simple models usually, but they try to get through a lot of data. Question answering, again, everything can be mapped to a question answering problem. What are the named entities in this email? What is the translation? Who's the president of Zimbabwe? Like all kinds of things can be cast as question answering problems, and every one of the sub-communities that we have currently in natural language processing and research, you can actually kind of see as a question answering problem. And then the same is kind of true for dialogue, and there are actually good question answering data sets out there right now. Dialogue is interesting in that also everything could essentially be a dialogue. In most cases, in current NLP tasks, it would be short dialogue. What's the translation? And then the next answer to that is a translation. But again, everything can be kind of cast as that. The problem with dialogue is that there aren't really any really good data sets. Nobody in the community is convinced, like, if we have, on this data set, we beat this kind of metric, we've made a lot of progress. In most cases in dialogue, you actually have to have people in the loop, which means you can't iterate very quickly on your models, and that slows you down, and so on. So dialogue is actually still kind of an open problem for a lot of things, and we have some papers actually at this conference, but in general, dialogue is hard. So we basically chose question answering as the one kind of framework in which we see all the other NLP problems as. And these are the 10 different kinds of problems that we want to tackle in the same framework with the same single model. Question answering, machine translation, summarization of longer documents into shorter paragraphs, natural language inference. So if I tell you, for instance, 400 people died in a plane crash, does that logically entail that 200 people died in a plane crash, that a plane crashed, that people went missing? Does it also mean, people went to the beach? Probably not. There's no correlation. So you basically classify whether a sentence is logically entailed by another sentence or not. Or whether they're contradicting, like nobody died and no plane crashed, that is contradicting to 400 people died in a plane crash, and so on. Pretty interesting general task in natural language understanding. Sentiment classification, super helpful for bots, for email classification and social media marketing, trying to understand whether your marketing campaign is working or not on social media and so on. Helps also knowing whether in a service case you want to escalate this to another tier and whatnot. Semantic role labeling, also an interesting task, mostly trying to understand text more clearly, trying to understand who are the actions, who are the agents of a sentence, what are the objects that are being manipulated, and so on. Relation extraction, trying to identify who's the president of which countries, who's the CEO of which startup, and so on. So you can go through a lot of text and extract different kinds of entities and their relationships. Dialogue here we call, it's pretty broad, but it's not really full dialogue. We're just doing dialogue state tracking, where you try to identify where in a conversation are you. Is this person, in a restaurant kind of conversation, they're asking about the food price. And then common sense reasoning is basically just a fancy term for pronoun resolution. So if I have a sentence like, the cat chased the mouse, and then it waited on top of the tree or it waited at the bottom of the tree. And now depending on whether it's the top or the bottom, it refers to either the mouse or the cat. And you know that based on your world knowledge of all these actions and so on. Anyway, so these are the 10 different tasks. And again, usually this would require 10 different kinds of models, 10 different groups in a big company that then try to all come together to build something more complex. We're basically arguing that instead of having a supervised learning framework where you have an input X and an output Y, which is basically the standard formulation for all the AI tasks that worked well, whether it's Go, where you have some reinforcement learning, it's a little different, but almost everything else like speech recognition, machine translation, computer vision, and so on, you always have some kind of input X, and you predict the output based on that input. And so input could be an English sentence, output is a German sentence for translation. We're arguing that we should go one level meta above that and include the actual task we're trying to predict. So we go to X, a task, or a question in this case, and an output Y based on those two inputs. And that is all you would want. You would want to be able to give thousands of these different kinds of inputs, an input document, a question or a task about that, and an output Y. And you want to automatically do this. And this is basically what this would look like. So here we have all these different kinds of questions given some kind of context, and we want the model to predict an answer. So this is the standard question answering formulation where you might ask, what is a major importance of Southern California in relation to California and the US? And it might be, it's a major economic center. And the answer here is actually a span in that input document. And that will become important later. You might ask, what is the translation from English to German of this context? And that's the output. What is the summary of this document about Harry Potter and so on? And the answer is a slightly shorter paragraph of a longer document. This is what I mentioned with entailment, where we have a hypothesis, like product and geography are what make cream skimming work. And you ask whether that's entailment, neutral, or contradiction to this premise, and the answer is they're actually entailed. Is this sentence positive or negative? And the coloring here actually shows you where you get the answer from. In this case, we actually, and that's important, learn that the answer is one of the words in the question. Whereas here the answer is a span, multiple words from the context. And the model needs to be able to do both of those kinds of things. And in the case of translation, as in blue here, you actually want to be able to predict words also that are neither in the question nor the context. All right, any questions about this formulation? All right, so even 10 years ago, if you would have said this is our goal, people are like, yeah, good luck. Like, I'll see you in 100 years. Like, this would have been impossible. It's really only in the last couple of years that we can now be so ambitious and try to basically solve all of these different problems. And it took us a long time to actually make it work. So basically, we want to have no task-specific modules. We don't want to have an if this kind of question, then run this other model kind of supermodel. That's not really what we're looking for, because then you're not going to get transfer learning capabilities between these different tasks. We want to basically be able to have the model adjust itself based on the kinds of questions that are being asked. And we want to eventually have this possibility for zero-shot inference on unseen tasks. So I ask a new kind of question, and ideally something interesting will still happen. All right, so this is our model, and we'll go over this. But the high-level idea is you have some context, you ask a question, and you want to generate an answer by basically creating one word at a time of that answer. And you can have three mechanisms for doing that. You actually either copy a word from the context, copy a word from the question, and these are called pointers, and you can also choose a word from an external vocabulary, which is just a standard classifier, softmax, logistic regression type classifier. And the pointers here will switch and choose, basically. All right, so this is the model, and this is for the 2/3 or so of the audience who don't know what an LSTM is. we'll just go over it very quickly. And don't worry if you don't really quite follow it. But basically, you have a series of complex types of neural network layers. And in the end, so you have a very high level an encoder that encodes the question and the context that you have. And then you have a decoder that basically can choose between these different word generation methods of copying or pointing towards an input or question and generating from a vocabulary. And I won't go over all the details here because I don't want to bore 2/3 of the audience, but essentially we use all the latest and greatest ideas from deep learning to make this work. We have pre-trained word vectors from a large corpus named GLOVE. We have character n-grams for unseen words. If you've never seen a certain word, you can still get some kind of representation. We use bidirectional LSTMs, skip connections. We have co-attention layers that will have outer products between the hidden states of both of those sequences. And then we have transformer layers. Transformers are a super new, interesting model from Google. They unfortunately are not the silver bullet for us. We try to only use transformer layers, but we had to still have LSTMs in there. We wish we didn't have to, because transformer layers are completely parallelizable, which is great for GPU computing, but we couldn't make that work. And then, yeah, we use a couple more LSTM layers and short circuit connections and so on. And then this pointer system here and this hierarchical pointer system is pretty important. So you either choose to generate words by pointing to them or by classifying a vocabulary words. And then you get a final word prediction, and you do that multiple time steps. All right, now I'm not going to bore you with all the different evaluations, but if you're an academic and you're at this conference right now in ACL, you'd be very, very skeptical that this is possible at all. So you'd be very, very careful about how we evaluate each of these with the various different metrics that each of these subcommunities has defined as the right metric to evaluate each of these tasks. We eventually will just basically sum up these 10 different metrics and define a new score called the DECA score, which instead of going from, most of these are going from 0 to 100, it will go from 0 to 1,000, because you have now 10 of them, and you just sum them up. And there are a ton of interesting things that are happening in this table, but maybe not interesting enough for an evening after a long day of work. So I will, and if you're not really deeply in the field, so I might go and skip through this, but basically our main model is the last one here. We have these various self-attention layers. We have a standard sequence-to-sequence model, which is kind of a good baseline now for a lot of NLP systems. So self-attention with these transformer layers, co-attention where the question and the input intermingle, and then this very important question pointer here where you were allowing the model to point to questions. And that is actually super crucial for these zero-shot kind of capabilities where the model can answer questions it's never seen before. And there, like I said, tons of interesting details where sometimes one thing really hurts a lot, and then combined with another thing gets a lot better. And the zero-shot classification of relation extraction actually helps a lot to train this together. So these first numbers here are all with the task trained separately and with the same architecture, but not the exact same model. And then all the numbers here are actually the exact same single model, the one I explained, trained on all 10 tasks put together. And there are a lot of subtleties also on how you actually optimize in that setting. You can't just throw them all in there and hope for the best, because there are some tasks here, like sentiment, which only has 10,000 training examples, and others like translation, which has hundreds of thousands. And you basically need to be a little bit clever about how you optimize this. And what's also interesting, if you had an oracle right now that would just basically say, I know exactly which task you're asking me about, and I will trigger this particular submodel that will solve only that task, you could actually get a slightly higher score than that single model that trains all of them together. And that is kind of surprising, because a lot of times you read papers that talk about transfer learning being so great, and we transfer from this task to that task and everything gets better. But the truth is, once you actually work in the field, most tasks don't help each other, they actually hurt each other. And if you're trying to train this great sentiment model on a translation, with a translation task, the default is it will do nothing on sentiment anymore, and will only translate because you have such a larger dominant training data set for translation than you have for sentiment. And so this gap is something that we hope to close in the next couple of months and years. And one of the reasons we open source this entire framework, you can download it, we pre-process all of it. In fact, I kid you not, the first 3 to 4 months of this project, we're just pre-processing these 10 different data sets into the same format. They're all tokenized differently. It was a huge clusterfuck, pardon my language. But we've had this idea for several years. Nobody wanted to do it because there's so much engineering that goes into it. So we knew people wouldn't take this task up unless we actually published it and it's open source. So now you have a Docker container, you can download the code, it will download all the data sets. We only work with publicly available data sets, no paywalls and so on, and you can actually run the whole thing. If you only have a small GPU, if you don't have a GPU, it's probably going to take 2 or 3 or 4 weeks even to train. If you have a single GPU, then you can do it in less than a week to train a single model on all of those tasks. And we have here this kind of trick with anti-curriculum. I'm not going to go into too many details, but for the most part, people thought that if you start teaching an AI algorithm simple examples first, and then you go to harder examples later, it will kind of work better overall. And that's called curriculum learning, like a person learning, having a certain kind of curriculum, right? You don't teach people crazy calculus before they know simple summation. It turns out an anti-curriculum strategy where you actually start with the hardest tasks, namely question answering, work better on this real domain and all these different tasks overall. This is an analysis of when does the model learn to point to the context, the input document, versus the vocabulary. So this is translation. It sometimes actually copies over words. So especially personal named entities. So if I have some weird last names like Socher, that's not in the vocabulary because it doesn't appear frequently enough, then the model actually learns to copy that word over in the translation instead of generating a new word. But for the most part, most of the tasks actually are quite focused on just one of the 3 ways to generate answers. So Stanford Sentiment Tree Bank, SST here, the sentiment analysis mostly just points to whether it's positive, negative, or neutral, which is one, each of these are words in the question that the model gets to ask. Now, why do all this? So here are 2 slides on already advantages that we can see. Similar to ImageNet pre-trained CNNs in computer vision, we also see that if you just take the pre-trained model that was trained on these 10 tasks, and now you'd work on the new task that the model has never seen, one, it will actually just kind of do something. So even when you don't train at all, this pre-trained model on DECA-NLP, for instance, for named entity recognition, so just identifying people, locations, and organizations in text, very useful task actually for email understanding, extracting structured data from unstructured text. If it's pre-trained on DECA-NLP, it'll already do something sometimes, but it's still way worse than state-of-the-art. But if you continue to train on that, the model that was pre-trained on DECA-NLP will still stay better than a randomly initialized model for that task. So if you have a new kind of NLP task, even if it wasn't part of the DECA-NLP kind of data set, you can just focus on that task, train it, and this pre-trained model will be slightly better than one that you just started from random. So exactly that dog that just keeps forgetting where it already bumped into, this one is slightly better. And hopefully the goal is for you to eventually just keep training that same model to get better and better on all the tasks that you care about. And I'm curious to see sort of where eventually that will just fail. You just have to train specific things. You cannot add more tasks to the same model. What I'm really excited about are some of the zero-shot domain adaptation kinds of problems. So we trained, for instance, on movie reviews, but then we asked the model also about reviews on different kinds of things, like instead of movies, some products on Amazon and so on, or restaurants. And immediately the model will work out of the box quite well already. And then, again, you can fine-tune it and make it better for that task. But it can also, instead of just saying positive, negative, neutral, you can give it another kind of input, like John had a party, and no one came, and he was all alone. And then you can ask, is this story happy or sad? And the model was never asked to classify happy or sad stories. It was never given training data for happy or sad stories. But it actually was correctly able to point to the word sad for that story. And that is pretty amazing. Like, nobody in NLP would assume you would have this kind of zero shot as in you had never seen it at training time kind of capability. And that's kind of what I'm very excited about, and I'm willing to go first a couple steps back to then go multiple steps forward to have these kinds of capabilities. And yeah, so basically we're, have this new benchmark. If you're in the field of NLP, but also if you're a practitioner, we think this is a pretty reasonable model to start any kind of language task that you have, and it'll probably just kind of work. That's our goal. But of course, the model could be faster, could be more RAM efficient to train and test and everything, and it could work even better when you actually put them all together. So I think the next step is a single multitask model for the field. I think it's time to bring all of these different subfields together and try to make it better, but I don't think we're fully there yet, which is why it's an interesting research problem. And now we'll have a bunch of questions. You can ask questions about this and all the other stuff like startup life and whatnot. All right, thank you.
Perfect timing. Awesome. Have a seat, Richard.
All right, right here.
Thanks, Richard. That was awesome. Guys, for those of you that don't know me, I'm John Henderson. I'm a partner at AirTree Ventures. And we have made a bunch of investments in kind of vertical applications of machine learning, from MetaOptima, which is computer vision for melanoma diagnosis, to Semantic, which is customer surveys, to Earth AI, which is mineral exploration, to Fluorosat, which is agricultural yields. This area is a real focus for us, and therefore I'm always fascinated when I get to hear from Richard. We're very lucky at AirTree that Richard's actually an investor in our fund, so I'm going to ask him some questions now, but if I ask him some bad ones, this is kind of like me interviewing the boss, so just bear with me if he gets cranky with me. Richard, I wanted to start off. I mean, this is astonishing progress. I think the reason that Nick and Susie let me speak here is not the investor thing. It's because I used to be COO of Sumly, which was kind of a summarization company that got acquired by Yahoo. We did very basic kind of sentence extraction, some sentence creation, which was basically stringing clauses together, and kind of looked at a Rouge score. It's astonishing to me that in kind of 5 or 6 years you can go so far ahead, combine 10 things, and I sort of wanted to kind of start off. I'm just going to ask some quick questions, and I encourage you all to chime in at any time. But just to get us started, I wanted to kind of talk, because you were running a company around the same time as us, and I wondered if we could go back to a bit of just extracting ourselves from the research for a second and go back to the company building part. Can you just walk us through a little bit of your background? Because I think ML is one of these weird areas where the research is actually being done within companies and within startups. So can you kind of talk us through a little bit of your time at Stanford, the PhD, and then the MetaMind story?
Sure. So I'm originally from Germany, and then I came to the US for my PhD at Stanford, and actually wanted to be a professor. For most of my years, I worked really hard to have more citations, more papers, more impact on the academic community. But then just when I had the offer, I was like, well, maybe I'll take 1 year off and start this company. And I had this completely unrealistic dream that after a year, I'll be chairman of the board, I'll find some other CEO, and they'll flourish, and everything is awesome, and I'll spend one day a week with them. And that, of course, didn't happen. And of course, one company was hard. It was also called MetaMind, because I was hoping to solve all these different kinds of problems. But of course, that didn't happen either. We really had to focus hard on making one particular thing work well. We didn't quite get to the meta part of MetaMind, and we were very focused. And so, but I also was teaching at Stanford at the time, and I actually realized it's fun also to see this technology actually work. And it's not just a research question anymore. And now that it actually works, there are lots of new things that come up, like ethical implications. Like, well, it turns out when AI didn't work like 10 years ago, you didn't really have to worry about AI ethics because it, was irrelevant. It wasn't running anywhere. And now it is. And all of a sudden we're like, oh boy, we need to be really careful about how we use it and so on. So basically continued with the startup, stopped the idea of being full-time academic.
And just for those in the audience who don't know the MetaMind story, can you just, what was the vision for that company? Like, what were you actually working on?
So the idea was to build, the very idea, beginning is a little embarrassing now, was to build the oracle of AI. So, what they did for databases, we wanted to do for AI. And that was a very unrealistic academic dream. But then it became more concrete in that we built a general platform to classify images and classify different kinds of text. And that was also interesting, and we had a bunch of users that built a bunch of classifiers, but where we really made money was when we started going into a specific vertical, and we had in the end two. One was medical and one was e-commerce. And medical was amazing. We literally saved lives. It was one of the first time a medical classifier was running in production, one of the largest teleradiology companies in the United States. And it was classifying intracranial hemorrhage, so brain bleeds and head CT scans. And they used it in this sort of pre-evaluation stage for FDA purposes, but they analyzed how often scans would come in and be at a low priority, and our algorithm would say it should be high priority. And they, in fact, changed it, put it to the top of the queue, and then a doctor looked at it and actually saw, indeed, there was a brain bleed, which can kill you in 5-10 minutes. And so if you wait for 20-30 minutes because of low priority, you just know why that person died, you wouldn't be able to help them anymore. And so the sad story of that was, though, that the person still had to look at it. So they didn't really save that much time, and they couldn't really say, we'll give it cheaper. And long story short, that whole project was about 50x more expensive for us to do as a company than the e-commerce one. It made more money in less time, just classifying whether there's a sink in the kitchen and a barbecue pit outside, and that just solved a very clear pain point for some e-commerce websites and made a lot of money. And it was those kinds of projects we would have had to do more of and less so of the others. But then we also realized that for AI to really work, you need three things. You need the data sets, the algorithms, and an understanding of the workflow of how to actually infuse the AI into something that people care about and how usually people do their jobs. And really in a small startup, in our case, we really only had great algorithms. We didn't have the data, and it took us a long time to convince companies to come and give us the data and so on, and we solved their problem. And we had no idea how people actually do like service automation or e-commerce and all these different things, and it turns out they're all very complex. And if I was to do another startup now, I'd actually not try to build a meta platform. I would go after one particular market, and that's also how I know you guys invest and how I personally invest too now.
Yeah, I want to talk about the way you're thinking about investing, but not quite yet. Because there was this kind of Cambrian explosion at that time, right? Like, I don't know who you consider your peers at that time, but DeepMind was around, Wit.ai was around, Alchemy API were around. Like, there was quite a few of these people working on the kind of the algorithm problem, and they all got acquired.
That's right. It turns out good algorithms are much more useful in the hands of big companies that have the other two pieces than they are standalone.
And was that a point in time? Like, is that opportunity still exist, or do you think?
I think it's very, very rare. I can't point to a single company right now where I'm like, wow, they're so far ahead in terms of the algorithms that it's very unique for them. And in fact, if anytime anybody tells you, oh, like we have the best algorithms, they're super proprietary, but they're way ahead of everybody else, I'd call BS on that. Like there's nobody right now. The community, and it's kind of fortunate, but even all the big companies, everybody publishes their best algorithms, and that's why, and there's open source tools and frameworks and so on. And that's why the field is progressing so quickly too, and it's much more about the data sets that are competitive mode now and workflow understanding that startups have. And that was also the case for us. So we got acquired by Salesforce after a year and 8 months or so, and now have a huge amount of impact in this very large company. It's actually been really great.
Yeah, and there's so many ways I can go from this. But the open sourcing thing, Google's released TensorFlow. I think Baidu's got Paddle out. You guys have got a whole bunch of stuff out. How do you think about that internally? Like, what's the kind of commercial discussion around let's have a research department which you run and then open source it all?
It's actually an interesting conversation. I think part of it has to do with recruiting. Like, really smart people want to see their stuff out there in the world and get recognition for it and have impact outside of their organization. Part of it is the academic community that just kind of set that as a standard. And it's very hard. So even companies like Apple that had for many years not wanting to publish anything are now being pushed to also publish some things. Newer, larger companies, as soon as you figured out how you make money, and you start thinking more than just like the next quarter and survival of a startup and so on, you start thinking longer term, like a couple of years ahead, you need to have a research group. And it turns out the top researchers that think for your stuff and work on your stuff also from time to time want to publish. So there's that. And then, of course, in some cases, like the DECA NLP, I actually think we will also benefit. If other people improve this kind of setting, this kind of model, we'll take their ideas and put them back into our products. And because we have unique data sets and understanding of workflows for sales, service, marketing, and so on, our own like company will benefit from that too. And then I think Google has a different, it's kind of in its own ballpark right now and its own sort of level. Like no other company has as many people, puts as many billions of dollars into papers. We sometimes jokingly say that some of the AI papers should be measured in like how much we increase the temperature of global warming because they put so many computing resources behind some papers. If you were a startup and you wanted to run the same kinds of experiments for some papers and you had to use AWS, it would cost you like $400,000 in AWS costs for one paper that Google publishes.
But your justification could just be, we're not a blockchain company, so it's fine.
That's right. And so long story short, it's a lot of recruiting and then a lot of good faith to improve the community overall, but they also know that the competitive moat comes from the data and the workflows.
And just sticking on this big company theme, why this research? Like, what you have, there's a million things you could be pursuing.
Right.
How do you prioritize what to research within a company like Salesforce?
So that's, I think, unique to us in some ways, but maybe not entirely. So I think part of it is just I want to advance the field. Like, I'm excited about AI. AI kind of spans everything from like what makes us unique as a species and so on, like really high level, interesting philosophical thoughts to like how do we make more money with advertisement? Like it covers everything. And on that sort of spectrum of like, okay, all the different AI applications, you have robotics for motor control and motor intelligence, you have vision intelligence, visual intelligence. I think language is the most interesting manifestation of human intelligence. It separates us, I think, the most from other animals. And so I think it's the most interesting, mildly biased, but I think it's the most interesting area of AI to work on. And so the beautiful thing, this is like, I think multitask learning is a big stumbling block for general AI systems. Like we'll never get to AI if you have one part of your brain that has nothing to do, that plays just Go, and another one that actually understands the visual world, and another one you talk with. Like it has to all be a single model that solves a lot of different things. We don't hit kids over the head until they forget the first skill they learned to teach them the next skill. It's just like, it doesn't make sense. It has to be continuous lifelong learning. So I think it's actually a fundamental problem of the field. But at the same time in AI, and that's part of the reason these big companies put so much money into research, it's also extremely useful if you build a chatbot to have a system that just kind of works on a lot of different things and isn't as brittle. So AI is in this magical place where big companies spend all that money because the basic research is often quite close to real applications. And that's not true for like, biology in some cases or theoretical physics. Nobody's going to spend, pay people outrageous salaries and compensation packages for doing theoretical physics in companies, but they do for AI.
Yeah, and so I wanted to ask you, speaking of Go and speaking of things that kind of work and are cool but not practical, had we sat here 3 years ago and had this conversation, I would have confidently said, it's all about data, it powers all the algorithms, whoever has the most data will get the better product, they'll get more customers, they'll get more data, there's this data network effect, incumbents are going to win this. Then we saw things like reinforcement learning and advances in discrete areas like board games and that kind of thing. What's your view at the moment about kind of where the opportunities are, how reliant progress is on data and kind of who's likely to emerge successful?
It's an interesting question. I think the three things are still super important, but the algorithms are fortunately getting commoditized through open source kinds of work. The data is still super important, but sometimes people are a little too scared of players that have a lot of data. Like China will have the most data on surveillance, and they will be the best in surveillance. But just because you have more and more videos of people walking on the street and whatever, doesn't make you better in biology and medical research, right? So it's like you have data about something specific. And in terms of workflows, it's hard to beat Facebook in social networking stuff. They're really, really good at that. They have all the data, they have networking effects from that and so on. They have good algorithms too. They're public, they also have great research, and they really understand how people interact and so on. So in some cases it all comes together, but I think the data is not this insurmountable thing. Like I have a lot of startups, even in the medical space, that say, one medical company that classifies red and white blood cells and blood samples, and it's super helpful for leukemia and various drugs that you want to be able to take as much as possible of that drug because it saves people's lives, but it also messes with your white blood count cells and counts. And so if you could continuously measure it, then you could take more of the drug and it actually saves people's lives. And this test used to require 3 days, actual person sitting counting white blood cells in these large measurements, and then coming back to you, and costs like $400, takes 3 days and so on. They can basically do it with some relatively standard convolutional neural networks, but they also have to build the device. They have to understand the workflow. They have to integrate it somehow. They have to work with pharmaceutical companies and so on. But they were able to collect enough data after a couple of weeks with their own device and so on. So the data wasn't the big problem. The bigger question now is like how do we integrate it into tons of different medical workflows for them to scale up their sales.
Yeah, it's a great example. And it's a good segue into where you, as kind of an industry expert in a big company, you're also an active angel investor in this space. You sort of hinted at it earlier around vertical applications, but maybe I think it might be interesting for the audience. Can you run us through kind of a couple of the more recent angel investors and kind of angel investments and how you've got to yes, and kind of where you see opportunities for companies without shit tons of data?
So I think you have to have a pretty clear focus on the market that you're going after, and that's true for every startup, whether it has something to do with AI or not. I happen to almost only invest in things that have something to do with AI, just because it's mostly inbound. I'm not an angel. I mean, I'm not a full-time investor. I just do this sort of for fun on the side. And so, basically what I'm looking for is whether they have a clear understanding. One, like they need to have some basic technical chops. Like you need to understand the algorithms that you're using. Yes, you can get quite far by just downloading Keras and running something, but if it doesn't work, you also need to be able to dig into it. You need to have, just basic machine learning 101. You have a train def test split and so on to not fool yourself into thinking you solved something. So there's sort of a basic requirement, but most of the people who reach out to me have like at least taken my class and they know those kinds of things. And so that is usually not like the biggest filtering requirement. Then you need to have unique data sets somehow, and either the ideas on how to collect them or how to partner with somebody to get them. And ideally, the collection process of that data is already something that doesn't just cost money, but you already make some money with it. So for instance, for me, the whole Salesforce CM game was actually really clever because they are collecting all the data about sales, service, and marketing, but they're actually getting money also for it, or store it, and so on. And they're making it useful before it's all automated with AI. It's already useful. They're making money with that. And then you need to have, in most cases, some actual industry expertise, and you need to have a founding team that really deeply digs into the space that they're in. So another one of my investments is a hearing aid company. And they really looked into all the hearing aids and they realized like they're all pretty crappy. They just make everything a little louder. So if you're in a restaurant and you have one conversation with like one person and there's lots of other stuff, it's brutal. You can't really, like, if you're hearing impaired, you don't want to be in noisy restaurants at all, like, because it's useless. You can't have a conversation there. And so it's a clear, like, machine learning problem too, and most of the hearing aid companies out there are not thinking about that, and so they're really clever going after the hearing aid market. Another one with the blood testing.
What's it called? You can tell you're a scientist. Give it a plug.
So I don't actually know if they
haven't
if
launched
they
yet?
fully
Okay, never mind.
came out. But there's a website. They're called Whisper. They're great.
Okay.
It's a great team. And then Athelas is the blood testing company, and they're just like brilliant founder. Great technology and a clear need. Like there is, that test costs $400 and takes 3 days. That sucks for any medical test. And if you can make that cheaper, there is a clear improvement in the world. The question then is, of course, do you have the right kind of salespeople who really have the right connections and so on to really push it out. But with the kind of founder who knows their stuff but is also willing to still get input and feedback and ask the right kinds of questions, it's just it's obvious to me that they're going in all the right places. Another one actually are Hugging Face and Replica. They're chatbot companies. It's a very different kind of game. It's like people talking to a chatbot as their sort of friend, which some people think is kind of sad.
Hugging Face?
One is called Hugging Face, like the smiley face, the Hugging Face, and the other one is called Replica. Similar, and what you can also see it as not like a friend for lonely people, but like a journal that actually asks you questions back. And then, Replica in particular had some really powerful stories where people were about to commit suicide, and then talked to their chatbot, and it sort of helped them work through their issues, and they decided not to. And
is this similar to that Microsoft released a Chinese chatbot?
That's right, yeah.
What was it called?
So in China,
Tay.
No.
That was
Tay was
That was the Twitter bot that became a misogynist, racist, anti-Semitic. Don't train yourself on humanity, basically.
So Tay had some really simple attack vectors that were just not even AI. You basically, one of the attack vectors was repeat after me, kill all X, and then it would just write kill all X. And screenshot, boom, it's racist, or anti-Semite or whatever. So some of the attack vectors on Tay were just really silly, but it's also the chatbots that people use for these companies. They don't want to attack them. It's a friend and a journal, and it asks questions and connects to your life, and so it's personal. You don't take screenshots of it and so on. So there are a bunch of interesting things, and those are very different kinds of plays, but and they're actually interesting in that there's a lot of NLP in them, a lot of hard problems. And it's interesting because to a researcher, I'm like, it's just a bunch of cheap parlor tricks. This is obviously not a real friend. It's not a real AI and so on, but it's surprisingly effective. People anthropomorphize a lot, technology, and we talk about machine reading, and if it's just, it's just like a bunch of LSTMs doing stuff. But it's powerful, it works, and their user numbers are going up and to the right, and it's a really interesting play. It's more high risk. In consumer, it's high risk, high reward, right? Instagram, if you could invest in Instagram, it's bunch of guys, 10 guys just building another photo sharing app. Flickr's already out there. Why would you care? And then boom, they blow up like crazy. So consumer is usually high variance, high reward, but also often very risky. Whereas in sort of enterprise space and medical and so on, if you have a clear value proposition of something the world clearly needs already, and you're making it cheaper, faster, better, more productive, and so on, then it's lower risk. But also you're going to make this amount because the test used to cost this much. You make it for this much. This done this many times. It's a pretty clear value that you can create. And then of course, as companies grow, they might grow into other things that also need to be measured.
Yeah, and you're saving lives.
Which is awesome, and I wish and this is a really sad thing, but I wish the unit economics for saving lives were a little bit better than the unit economics of advertisement or something like that.
Look, I could talk about this, as you know, all day, but I know you have a dinner to get to, and I want to make this more of a broad conversation. I've got a million questions, and I will keep going, but if I'm sure there's a lot in the audience, both from the presentation and from this, so I'll start. We're recording this, so I'm going to sort of repeat your question a little bit, but go for it.
So it's a technical question going back to deck NLP, if that's okay.
Sure.
It's relevant, I guess, to zero-shot domain adaptation. I guess my thoughts about language modeling as a task and using things like complexity as a metric of evaluation, I've always thought that that's not a good way to look at things, because essentially all we're trying to do is memorize a specific sequence, and if you give a presentation, the way you memorize a sequence is not necessarily the way you verbalize it. The thoughts in your head but the way it comes out is not exactly how you internalize that. I might have missed it because I was sort of ducking in and out with the Deca NLP presentation, but how do you see that generalization? Because I mean, I guess historically the way we try to combat that is by regularization or whatnot, to try and smush things together to come up with something that's human interpretable. How does Deca NLP, or how do you think Deca NLP is helping in that respect to generalize beyond this idea of, well, let's just regenerate, or let's use a pointer network to pull something from our source document?
Right. Yeah, so all models end up overfitting usually to some kind of domain that they're in, and if the model doesn't overfit, the people who are working in that domain start to overfit their thinking into it, so sort of higher level overfitting. And Deca just has, it keeps you honest, and it is brutal because it's so ingrained in how we do research. We also had this, I had tons of ideas. I'm like, oh, we know for this thing, that kind of module for deep learning should work better. We run it, and yeah, it worked better on 3 things, but it hurt on 6 other things. And we're like, oh man. So we kept going into different directions and then had to go back to the original model because it wasn't a real improvement. And so it keeps you honest to have to try to run it on 10 different things. You can't just tune your hyperparameters really, really well and just hill climb on that. And it requires, I think, a new way of thinking about the problems. And then in some ways, all evaluation metrics in AI are flawed, but in aggregate, when you have 10 of them, they're slightly less flawed, surprisingly, than 10x flawed.
I've got a better version of me repeating the questions. I'm going to hand you microphones. I'll come to, there you go there.
Thank you very much. Thanks, Richard, for your talk. I actually have 2 questions which are related to each other. So the first one is, according to your experience, how realistic or how difficult will it be if we, using NLP, we not only want to give proper response, but also we want to predict what the next best action is according to the conversation?
I actually think next best actions could totally be cast into the Deca framework. It's just based on what you just read, what is the next best action? You train that, and it learns to just generate that. I actually think in various online interfaces, next best action kinds of problems should also be cast as sequence problems, given a bunch of inputs, words, or, and this is kind of technical, but each of the previous actions you took could also be represented as a vector, just like a word could be represented as a vector. And you feed that into your sequence model, and you just try to predict the next one.
So what if the data you need goes beyond your current conversation? For instance, taking your John example, so nobody came to the party, so he felt sad, and he called a counseling service. And the robot, instead of, or in addition to kind of comforting him, also can say things like, maybe it's time for doing some exercise. And then not only that, they can prepare for the answers like, there is a yoga class beginning in 20 minutes, just 2 blocks down, and there is another blockbuster movie which is interesting according to your history, whatever. So in terms of data, does that mean you have to prepare for a lot beyond your current conversation to guide your next best action?
So the data problem is always sort of there, and yes, you're not going to predict to give somebody that answer to go do exercise unless you've seen in somewhere in your data before that exercise has helped somebody before. So in that sense, it's not going to solve things that far out. But I don't see, again, if you've seen that before, this model will be much more likely to be able to generalize and reuse the ideas of okay, this person didn't say they're depressed, they said they're sad. This person didn't, predict exactly to do yoga, but they're doing, I don't know, soccer or something, and then you basically generalize across those kinds of things.
My second one, I will be quick. So what's the best solution to tell if someone is being sarcastic? For instance, if John, again, using your party story, response is great, then maybe he is taking on your advice to do yoga. But if he says great, maybe he means another insensitive piece of advice from a damn robot.
Right.
So what's the best solution?
People love sarcasm and sarcasm classification. I have in my Stanford class every year, there are a couple hundred students, and at least a dozen or so always say, I want to have my final project be about sarcasm classification. I'm like, don't do it. It's not going to work. And if they ignore it, it never works. Then they end up like last minute switching to standard sentiment, which is positive, negative, neutral, and then like move on. I think sarcasm, there are some data sets where people just took tweets and then they, that ended with hashtag sarcasm, and then just deleted the hashtag and then took that as a positive training example. And I think you can get to a certain bar with just looking at text. And it doesn't even matter what model to use or which AI you use. Just assuming that sarcasm is a text-only classification problem, you can get to a certain level. But to really push beyond that, you would then have to include a lot of other kinds of data sets. You have to know the person who's saying it, the audience that they're talking to. And you can come up with sentences that are like, I was coding all weekend. What a great weekend. And I can tell you that there's some people in the world who hate their job, who had to program for their job, and they were being sarcastic about that weekend being great. But I also have friends who love coding, and like their day job doesn't allow them to code as much anymore. They have to talk to people all the time instead, and they just spent time coding, and they loved it, and they were not being sarcastic. And so it's just like you need to know something about the person. You need to have some kind of person embedding. And then, based on all the previous data and so on, you might be able to get a slightly higher, but nobody has that kind of data set, so it's a really tricky problem to work on.
Great, thanks. And that grade is positive, not being sarcastic.
Thank you.
Yeah.
Just a question about the your architecture that you described before. You mentioned that you use glove plus character embeddings. Was there a principled reason for using those embeddings as opposed to, say, fast text, which also supports out of vocabulary words? We like fast text. It's a great embedding too. You do want to ideally be able to backpropagate into your vectors and change them. At the same time, for instance, Squad that has a lot of questions you've never seen before also about domains you've never seen at training time. You have to have a really good pre-trained model. So fast text is really great pre-trained, but it's harder to update it sometimes. But it's actually a reasonable thing to try, and it's just because we've tried so many things that we didn't have like a nice evaluation on that. But yeah, fast text is good stuff. Byte pair encodings are also great, and I think in general we want to, instead of having word vectors that are pre-trained and then having character n-grams that you kind of backprop, you should have character n-grams that are pre-trained and really good, give you reasonably good word representations for most of the time, but then it's much more robust to outer vocabularies and so on.
Okay, I'm on mute, sorry. So I had two questions. The first one is starting off from where the next best action you mentioned. So she mentioned that there can be like two things about it, but if a person says that, okay, he or she is in so-and-so situation or in an emotion, so can the next best action be like a list of alternatives? If so, on what basis is that decided? And also, will it be confusing to provide that to the person? It's like,
I don't quite follow the question, but like, I guess in general, it just sort of depends on what domain you're in and what your training data is and the task and the workflows that you have. So I think in general, you can have all kinds of things embedded as vectors. In fact, once you realize that everything in the world can be embedded in a vector, you've made a huge amount of progress, and then you realize that deep learning can work on all the things that you have a lot of training data for, because that's just taking in vectors and producing other vectors that include distributions over actions. And so next best action to me is just another sequence problem where your inputs aren't word vectors, but they're state vectors or concrete action vectors that you backpropagated into. In fact, reinforcement learning also sees actions as vectors most of the time now. So I don't have any more like deeper insights into your question.
That's
but
okay.
yeah.
The other thing, it's a general question, it's not technical. Back when you started with AI and or rather when you invest now, have you encountered like target users or audiences who have expressed their fears of using AI? And if so, what were they?
So I guess most of the startups are excited about it because they think that's part of their company culture and so on, and unique IP and so on. I think most people are worried about their jobs. If the jobs are kind of boring in some sense and very repetitive. So if your job is very repetitive and you feel like a robot could do this, chances are probably in the next 10, 20 years a robot could do it. So, and it's kind of interesting, and it's a tough thing to talk about sometimes, because it's clear that AI will have a huge impact on jobs. It's actually not always clear what that impact will be like. So I give you 3 examples from Salesforce, sales, service, and marketing. In sales, if you have an AI algorithm that makes you 50% more productive, your company isn't going to say, oh great, let's fire 50% of our salespeople and go back to 100% of sales, like of the original one. No, they're just happy they're making 50% more sales. On the other hand, if you're in service and you can answer 50% of service requests that are coming in, a lot of companies see that as just a cost center, not a differentiator, not a revenue generator, and so on, and they might actually cut 50% of their service staff. And so if you're a CEO of such a company, you should now think about what happens to your employees when that happens, because it will be more efficient. Customers are usually happier if they get the right answer more quickly, and so on. So you can start thinking now about those people and maybe help them with using their skills and their interpersonal skills to resell and upsell after an algorithm gave the right answer really quickly and your customer is happy. And then in marketing, I actually think new kinds of jobs will come out for people who understand that they can now say, I want to create an algorithm and work with an AI system that can go through all Twitter images, find my company logo, then run an NLP algorithm that says, is that positive or negative? And if my logo was seen in the image and the text was positive, let's have a person go through those remaining tweets and retweet them if we want them to help in our social media presence. And if they're negative, maybe we should trigger a service case. So like that kind of thinking, once you have it, will actually allow you to create all kinds of new marketing opportunities, and it's new kinds of jobs. And then there's sort of the meta level on the whole economy and in general. And there I think we have seen as humanity a lot of sort of step function changes, like automation of the Industrial Revolution, like changed a lot of how people conduct their day-to-day lives. So 150 years ago, over 90% of people worked in agriculture. I'm pretty sure 90% of this room is happy that they didn't have to work all day in the field. Those are not great jobs, right? But at the time, if that's the only thing and you see a tractor just like go over the field, you're like, damn, like what else are we gonna do? We just need food and shelter, and then we already have a house, and now we're getting food automatically. There's nothing else for us to do. People will always find some fun new things to do. And I think just like nobody worries about tractors now, I think also like driving, like truck driving and stuff that will happen with self-driving cars, those are also like kind of like not the most fun jobs. In fact, there's a huge shortage right now of truck drivers in the United States because you just sit and you go straight sometimes for 200 miles and like nothing happens. And an algorithm can and probably should do that. People can do more interesting things. Anyway, there's a pretty complicated conversation about fears of AI, and there's some unfounded fears, but yeah, I'll leave it at that.
I might take 2 more questions because I know Richard has to dash soon. One here.
Thank you. Thank you very much for the very enlightening talk.
Thanks for coming.
So I really like the idea of being able to train across so many data sets. So what you've done is basically take all the existing public data sets and train them together. And in each of those data sets, the people who curated them did it for a purpose of solving that particular problem. But you're trying to solve a more general problem. So if you were given a limited budget on creating more data that will help you to advance your objective, which is this sort of general framework, what would you spend that budget on?
That's a cool question. One I haven't heard before. Because also the whole DECA thing, we only came out a couple of weeks ago. I think probably a good combination of more things, like actually having question answering, questions that require so-called multi-hop reasoning. A lot of the times the questions that you've seen here really only need that one paragraph to answer that particular question. But sometimes people actually combine multiple different facts. Like they go in a database, they run a SQL query, they get some statistics out, and then they look at a document that talks about a whole market, and then they give you an answer to make a prediction. And so the trouble is that those kinds of questions are not that common, but that's kind of where we think real AI will come in. And a lot of the kinds of tasks that we now have and the data sets that we now have, 90% of them you can solve with just finding a single website and the phrase somewhere is the right answer. In fact, that's also true for Google and search engines and so on. Like the majority of things are answerable if you just have all the websites in the world in your index and you just say this is the answer right there. And you don't have to say, oh, I know this is the aunt of that person, and now I'm like create this knowledge graph of different relationships, and then I can reason over that graph. But that's kind of where a lot of the interesting AI will come in, and those will be more interesting data sets to collect.
And then right next to you. Oh.
This is a really quick question. With the current generation of Deca NLP, is there a practical length limit on the sequences you can use with it?
Is there a practical limit on sequence to sequence?
On the length of the sequences you can put into it?
Great question. So one of the papers we had at ACL actually yesterday shows how to make these kinds of models faster, because with all the crazy bidirectional stuff and co-attention, they're actually too slow to run on like a really long, even just lots of long documents. And so what you would often do is realize that most of these questions are answerable with 1 or 2 sentences. So you run a sentence selector model, a classifier model based on the question first, and then you run all the fancy co-attention stuff on that after. That's one simple way to do it. Another cooler way would be you can actually run a powerful but much faster model on all the things, but we're working on that right now.
Nice one. Look, guys, I'm gonna wrap up the questions now. That doesn't mean we can't keep talking. That's kind of the whole point of this event. A couple of quick plugs and a couple of quick thank yous just to wrap up. Plugs for Salesforce, obviously. If you're a data analyst and you want to go somewhere that has lots and lots of really interesting data, then Salesforce should be top of mind. If you want to go somewhere a lot smaller or found your own company, come and talk to AirTree Ventures. I'd love to speak to you. And then in terms of the thanks, huge thanks to Nick and Susie from the AI NLP community.
And also Emily from AirTree Ventures, who isn't here tonight. Emily did a great job, so shout out to Emily.
But this is a great audience, and it's wonderful of you guys to be pushing this community, and it's great to see so much interest and really great questions from down here. And then finally, obviously, it's a pleasure and a privilege to have someone world-class and cutting edge of the field come down and visit us in Melbourne. So thank you, Richard, for your time.
Thank you. Thanks to you all.
And thanks to everyone.
Thank you.